And welcome to the Sandhill and Casewise Stepping Up to Enterprise Architecture. Everyone has been placed on mute, and we've got our panelists with us that we will introduce shortly. The goal of this webcast is to present how users can step up their enterprise architecture using one of the leading enterprise architecture and process modeling solutions in the market, starting with a strong foundation of data architecture. We'll be highlighting ERwin together with Casewise Corporate Modeler, which allows you to evolve your process modeling needs today and in the future, leveraging tools, standards, and best practices. As an FYI, we will be recording this webcast, and we will also send out the PowerPoints to the attendees as well. In the panel that you've got on your screen, if you've got any questions, because everyone's on mute, please go ahead and type in your questions. And what we'll do at the panel at the end, we will regroup and answer those questions. We will do our best to answer all questions that we get by the end of the webcast. And if there are any remaining questions that are unanswered, we will then send them out with the PowerPoints. So let me begin by handing this off to Don Soulsby and Dina. And Don will do the introductions for Don and Dina. Don.
Thank you, Robert. We are talking about the two companies presenting today, Sandhill Consultants, and as you can see, we're founded in 1989, not so coincidentally as the same time as Casewise was founded. We in Sandhill work in the standards, training, and enterprise modeling community. We provide services and technical support, and as you can read here, we have offices US, UK, Canada, and South Africa. I am from Sandhill Consultants. My name is Don Soulsby. I'm the Enterprise Architecture Practice Lead, and I've been around the enterprise game for going on 30 years. Starting in 1988 with 4 guys who don't program anymore, basically sitting around one evening going, gosh, we better do this a better way because we certainly aren't doing a lot of projects on time, on budget. And what I started to look at, frankly, was how we could do things a little better from a modeling perspective. From Casewise side of the house, we have Dina Freed. She has over 14 years of Casewise experience. Dina's role includes pre-sales support, training, consulting, engagement management, training development, and other aspects of the complete software sales cycle from evaluation to implementation. Dina is also responsible for the management of key clients' technical support, and she is the owner and editor of the TMF framework model, including its publication, distribution, and configuration. So without ado, let's move into enterprise architecture. First thing we should do, obviously, is define what architecture is. Typically, from a building or ship perspective, it is the art or practice of designing and constructing buildings, or frankly, ships. The secondary definition that they have in Oxford Dictionary, which I found quite compelling, describes architecture more or less from an information perspective. The key word there is complex and carefully designed. It's obviously questionable sometimes whether we build information systems carefully and we actually get around to designing them. The important part here, though, is the conceptual structure, logical organization of a computer or computer-based systems. So that's basically, if we're talking about architecture within our context of information and systems, that's basically what we're looking at. If we want to look at a bit of the world, about 25 years ago, or going on 30 years ago, there was a movie called Towering Inferno. And it shared something with a more recent disaster movie called The Titanic. And if you've ever both movies, the first thing they did when they were poised with a disaster was to pull up the structural plans. If you think about it, disasters are nothing more than an acute form of change. In point of fact, it's change that has been inflicted upon you, and it is how you react to that change is really how you describe a disaster. Well, in our world, in information systems, the building plans or the construction plans that we look at are, in fact, our data models, whether they're the physical model of the database or a logical or conceptual model of what we're looking for. So therefore, a good place to start with architecture, if we're talking about change, is our data models. The more important part, of course, as it applies to change, though, is how does this data attach to other parts of the business? In point of fact, how does it connect to the processes, the applications, and technologies? So if something in the data world changes, or something needs to change in the data world, really we must look at questions such as what are the processes that are impacted, what are the technologies and applications that hold the data, and what people or organizations will be impacted by that change. Could be the flip side of that, though. It could be the organization changes. Well, what is the impact on my data? So change can happen anywhere in an organization, or it could be the organization, and we need to understand the impact on all of the systems. And by systems, we're looking at the data and the applications. So today we're going to look at a bit of the challenges of what happens in a case where you need to make some changes. We're going to look at the architecture from the perspective of a strong foundation, which in this case we're advocating is your data architecture, and then to look at the impacts of change, whether the change comes from the business side or, frankly, as we've seen with new technologies, can come from the technical environment as well. We'll provide an example of how to step up to enterprise architecture with the specific case related to governance and stewardship. Then we'll take a look at how we theoretically can do this notion of enterprise architecture and look how specifically it is implemented in the Casewise tool. The business drivers, again, they do not change a great deal from time to time, but typically, as we've seen, there is always the issue of the business and IT alignment. The technology and businesses change. What do we need to rationalize within that? Regulatory compliance is always there. Laws always change. Our need to change with the laws. But I think some of the aspects that we're looking at most importantly is things like complexity and risk. And how do you manage those, particularly in cases like a merger or acquisition? Part of the problem that we're dealing with is the fact that a large number of our applications that have been built over the years have fundamentally used an industrial model. If you look at our good friend Adam Smith over there, and he talked about in his books about economics, that there is scale, and you can always solve a problem by breaking it down to its smaller parts. It's very much the scientific method. As a result, a lot of our systems that we've built are actually built along organizational or process decompositional lines. In the initial aspect of building those applications, obviously, whoever built the application owned the data that came as a result of the system. But what we've found over the years when things started to change, that we may have built our systems that way, but the thing that was responsible for building it, such as the organization or the set of processes or the process decomposition, has changed. And as a result, then, we've built this highly complex network of now what used to be a very linear relationship between the top to bottom of the pyramid now is quite complex. As a result, when you try to do change, it is a bit of a spaghetti diagram because you're not entirely sure when you want to do something or change something on either side of the business or technology realm, what actually is going to come along with it. In other words, what is the impact of that change? Emil Saarinen, who is the father of Eero Saarinen, who was the architect of the St. Louis Arch, has said that when you're considering anything with architecture, always design a thing by considering its next larger context. A chair in a room in a house in an environment in the city plan. And the same is true of data then. As we start to look at the data components and the data architecture, we need to look at it in different levels of abstraction, or as he's calling it, the next larger context. So as we look at the world today, we have gotten somewhat more sophisticated in our approach to dealing with information architecture, and we see evidence of that by the object groups framework. We see it in the Department of Defense architecture framework, and certainly anybody familiar with John Zachman and the Zachman framework. So all of these fundamental frameworks are approaches to doing architecture within an information context. You'll notice in the DODAP model, I'm not too sure if it's clear enough in the picture here, but the underlying pyramid or base pyramid is the data model here, and you can certainly see in John Zachman's work that the first column is actually the data column. And I've asked John about that. I said, well, is there a coincidence that you're actually starting with data? And the answer is probably not. So again, we can see from the two modern sets of architecture that data architecture seems a very strong foundation. If we talk about architecture, and again, we look back into history only being about 20-odd years in our business in terms of enterprise architecture, we saw the term DAT, Data Application and Technology. It was very much related to the functioning systems, and we really were talking about databases, applications, and the physical network they were running on. In point of fact, John Zachman's enterprise architecture originally only had 3 columns, which were the what, how, and the where, which effectively became the data, application, and technology architectures. Really, when we started to look at how we build systems then, in the late 80s, we heard the term information engineering. So that basically said we start with a data model, But what is very important to understand is its relationship to the process model. And the term CRUD was coined, which stands for basically create, review, update, and delete. However, as we started moving into multi-tier systems and multi-tier networks, and particularly client-server, we realized then that the process model itself now has to be spread across the network. We had clients, we had mid-tier, and we had backroom servers, and the question then became, where does the process reside that is actually performing the work, that in point of fact is attached to the data model? Now, as we progress into these days with the internet, the concern now, of course, is security, and how and who does a person interact with a specific process model. So as we moved into the cloud and into the web world, the concept of access control became very, very important, and fundamentally understanding the human interfaces. So effectively what we're seeing now in terms of a modern day architecture is not so much the hierarchy, but really this kind of network model that deals with a set of relationships that talks to data, process, organization, and location. And I guess the important thing about that understanding then is if I were to tug on one piece in any particular area, you'll notice then it is connected to all the other things. So to help us understand change, we have to understand the relationships between all these things. And in point of fact, we actually have three different domains, if you will. The business domain has that set of relationships, the technological domain or the design domain has some, and then there's the physical operations. So as we look at change then, we might take a look at how the business changes. We forward engineer into the technology environment, and if there are certain things that change in the operational environment, such as new technologies, we need to reverse engineer them to this common model, which is the technological model. So if we look at planning for change then, we always talk about the alignment of the business and technology domains, and if we have something new that changes, such as an innovation, we need to take a look at what impact that innovation has on the business models, on the impact that they have within their own models, and then to extend them over to the technology models to see what change is required there. However, if we have some change in technology, such as big data or the cloud, rather than just making an impact on the technological models, we really should look at the potential opportunities in the business domain and then cycle back through the business models down to the technical models. So in point of fact, what we're doing is this kind of concurrency of engineering that basically does this concurrent reverse engineering of the technical models up to the business models, and then the forward engineering of the business models to the technologies. In point of fact, if we go look at the Zachman framework for enterprise architecture, and we start with our solid foundation, which is the data column, we said we were going to do reverse engineering and forward engineering. We effectively meet in the middle at the logical data model, and if we've done a good job at designing our logical data model, we have the impact of the business change, we understand the potential of the changes to the databases, we can then express that change outwards into the other areas that we mentioned in the enterprise architecture. So really, as we're saying about talking about stepping up to enterprise architecture, we really are starting with the data set of information and then looking at the impact that it has, as we said earlier, on the processes, the organizations, and locations, and then also by looking at the technology domain, what applications or technologies might be impacted by the change. So in that case, we'd like to give you an example here of how this would actually work in the real world. Let's talk about governance. I particularly like this quote from Larry English, that information governance is the act or process of directing, leading, and assuring the information is managed effectively as an enterprise resource, including resolving information conflicts across the enterprise. And that whole notion of information conflicts is an interesting aspect that we'll now take a look at. So as we mentioned, we're going to start with our very firm foundation, which is in the data architecture world. And as you probably know, the logical, physical, and data models fall into what we call enterprise relationship diagramming, and that is really your data models. Above that, we have our conceptual models, and then we have our physical databases below. So really what we're talking about is the management of those models becomes the fundamental core of everything we're doing within the data architecture. Who is involved then? Well, we see the governance councils typically at a higher business level, and within the area of model management, we see the data architects, the data modelers, and then the DBAs, and frankly, sometimes the testers of the actual applications. And we know for a fact we can do a pretty good job of forward and reverse engineering within the data management process because we actually can do literal transformations. We can reverse engineer the databases into a physical data definition, and then from there create a physical model. And in ERwin, we can create a logical data model as a result of the conceptual models, and we can go backwards and forwards between these models as we make changes. And we can also understand the impact of change as well. So what we wanted to look at today specifically was in the area of stewardship. Stewardship is a fundamental issue that we're dealing with, again, as we were saying from Larry Inglis's quote, that if we're looking to figure out what the information conflicts are, we need to go to a subject matter expert. In this case, we're calling those subject matter experts stewards. But as we found out, because we have the three domains, the business, the technical, and the operational domain, that there is not a single data steward. In fact, there is a relationship of different stewards to the actual information that they are to manage. We are looking at in terms of a RACI chart, which again, fundamentally for what we'll be looking at today is responsibility, accountability, and whether you're consulted or you're informed. But we also have to look at the form, the structure of the data, and the data content if we really want to talk about stewardship. Today we're going to be looking mostly at the structure of the data, or in point of fact, the structure of the metadata. So if we want to look at the first part of any database, really that databases are simply a matter of columns and rows, call it structured data if you like. The first area we want to look at is what I would call the government steward. Now if you look at those folks, they are responsible for the decisions about what data the enterprise will collect, and as a function of its collection, how will it be maintained, and what it look like when it's in the databases. To some degree as well, they need to specify what are the data quality parameters as well of how you're going to collect the data. So they are in fact the representation of the data creators. The second thing we want to look at are the rows in a database, and I would call them a process steward. Effectively, they are responsible for the decision about how the enterprise will collect and maintain the data represented by each row. So they represent the data consumers. The reason that I think they call them process stewards is because if you look across a large organization, there may be several instances of how you create a customer. And in point of fact, when you deal with large corporations that actually have entities that are reporting to that larger corporation, in point of fact, how they actually do the data collection for something like customer may be very different. And also in point of fact, depending on when you collect the data about a customer, whether they're a new customer, a returning customer, the process by which you do that also could be somewhat different. So it's the data consumers that really represent the process stewards. Well, the question then becomes, how do you discover, if you will, who these data stewards are? And this is an interesting situation where we're going to look at now how you can use the combination of data models, process models, and organizational models to help you understand who in fact are your candidate data stewards. So if we look at the diagram here and we start once again with our data model, if I were to say I was looking for a governance steward, I would look at the relationship of the data to the process, and I will also look at the relationship of the process to the organization. Effectively, there are two sets of matrices that I can extrapolate who the stewards are by the following axioms. As a governance steward, what I'm effectively looking for is the organization. I look at the RACI chart that is accountable. Then I look at the process side as to who creates the data. And in particular instance, let's say it's customer. I look at customer. I look at the CRUD. Which process creates customer and who is accountable for that process? We'll give you a good sense that they are the persons that are responsible for understanding what the organization, what the enterprise has chosen to collect. If I then wanted to look at process stewardship, I could devise those by looking at, once again, the organization. And I look now for the responsible folks for a process that either creates or possibly updates or deletes the data. So by doing that then, the stewardship for process, I can see the relationship of the organization to the data that I can derive from a RACI chart and a CRUD matrix. So that's theory. Let's talk a little practice now. I'd like to hand it over to Dina, and she can take us through this exercise you've just seen in the Casewise tool. Dina.
Thanks so much, John. So as we can see on the next slide, the logical data model that we're starting out from is actually coming from ERwin. So this will represent the data part of the triangle that we just saw on the previous slide. So if you look at this, this model, we're starting out with entities. We're looking at their attributes, their relationships to one another, and that's the logical data model, and that's really sort of the starting point for bringing information into Casewise. And when we look at it in Casewise, it initially looks very similar to how it does in ERwin, which is great. So that's your logical data model. So you see the same information, the same sort of information. And as you see the transformation to the picture on the right, what we're doing there is we're actually leveraging information that was in ERwin, which was actually a user-defined property, and we're able to take that information and visualize it. So this is something that you're not able to do in ERwin, but in Casewise it's very easy to do, to visualize any property, even if it's a user-defined property. In this case, it happens to be a classification of whether something is a private or sensitive information or whether it's public. So the ones that are public are red, and the ones that are private are green. Actually, sorry, vice versa. The private ones are red, public ones are green. And so that allows you to, at a glance, be able to see, sort of what's important about this information. And as we go through the next few slides, you'll start seeing a little bit of that. So this is really the first thing we do is we bring the information in, and then we look at a process. And the process flow in case, as you can see here, has steps. And each step that has a little blue icon in the bottom left corner actually has data linked to it. So what we do is we take the data that's in ERwin and we tie it to the processes. And so once we see the relationships created, you'll actually start seeing these entities kind of pop up. If you hover over the blue rectangles, the entity or data names pop up and you can see them, you can get more information. So what this diagram shows you, this process flow with entities shows you, is that you're actually taking the processes that were already in Casewise, or maybe your business analyst built them, and you were tying them to the data that came in from ERwin. And so then if we look at the next slide, we're able to see how those relationships are made and if you have any gaps. So in this case, we have a rule that you must have at least one creates per row, and the customer entity only has a reads and updates, and therefore it's showing us as an error with a red X's. And this is a CRUD matrix in Casewise, and this is probably one of the easiest ways to link the relationships, to create the relationships between entities and processes, to really create that CRUD matrix, that CRUD relationship that Don was talking about. So you're taking your data and you're linking it to the process. And in addition, the swim lane we were just on a minute ago, where you're putting the processes and linking them to the swim lanes, into the sales swim lane which is behind it, that creates the relationship between the processes and the stewards or the organizations. So if we take it one step further to look at the data impact analysis, one of the things that you can do in Casewise is that you can actually create these relationships from the model. So the model, which is in Casewise, stores the information about your applications, technologies, business rules, things like that. You tie them to the processes. And this diagram is automatically created for you just by using the relationships that are in the model and leveraging the information. You can see we have lots of different visual indicators on the technologies, applications, etc. But what we're doing is we're trying to leverage the information between Casewise and ERwin, and it's all sitting in Casewise, and you're able to see the information and the relationships between the processes and the data, and also the processes are linked to the stewards. And then what we can do is once this information is in the repository, we can actually pull it all out into a report. And the report that we're looking at, first of all, it has a table of contents that you can include. You can include an index. You can include any diagram that you might publish that might have text behind it will come out with that text, as you can see on the screen right here. So here we have a figure, and you can see there's quite a bit of text, and it goes on for quite a while. And that's really your underlying information that's sitting in your repository. You're pulling it out into a comprehensive report that you can share with a lot of people. And then on the next slide, what you can actually see is the indirect relationships between the data and the stewards for the data. So the stewards are linked to the processes, and the processes are linked to the data. But what you can do with this report is pull that out. So you can pull out indirect relationships. So this allows you to see that, for instance, free gift is tied to sales, while product is tied to manufacturing, service is tied to service desk, and You can also see when there are no stewards present also. And so this information you can pull out of your underlying repository, and really this kind of brings us back to that triangle that Dawn had, where you're able to see it through all 3 pointers of the triangle. And I think, Dawn, now it's back to you.
Thank you, Dina. So what we're looking at now is kind of a bit of a chart that shows and describes the activity that we just performed by looking at how to derive our stewardships by the set of relationships. So effectively, as we start to look at it now, from the beginnings of the data architecture perspective, so if we look at the upper left-hand corner, we see there's an implied business change that is coming in, and we can look at the conceptual data models, their impact on the logical data models, and we can reverse engineer the physical world and vice versa to see how a change in the business would have some impact on the data. And then as we saw with the integration with Casewise now, we can go over to the similar set of models that are in the process domain, the business dynamics model equivalent to our conceptual data models, the systems dynamic model relatively similar to our logical models, and the function dynamics models are all different types of process models within the Casewise modeler. And if we now look at the bottom side, we can see the application and database change that happens as a result of seeing an impact of any of the changes to any particular areas. So it could be that the application or database change is needed from the technology side on the right, which may have an impact on the process change. For example, moving to the cloud or a consolidation of data centers is a technology change. But we do want to look at the impact on the actual business models that are related to that change in technology. And of course, as we know from doing any sort of process modeling, or frankly any process design, it is always important to have a set of tools and technologies that support being able to do it. So in this case, on the data modeling side, we are advocating the use of, obviously, of ERwin for the data modeling side. And on the process and enterprise architecture side, it would be the Casewise set of tools. Beyond that, if we go back to, for example, the IDEF models, that model basically has stated that every process should have defined sets of inputs, defined sets of outputs, tools and technology, but also a set of standards and best practices. This is where Sandhill comes in. Today we have our enterprise set of standards for data management, enterprise data management, and in conjunction with Casewise, we are also working on a set of enterprise process set of standards. So as we see now, as you're stepping up to enterprise architecture, starting off with the ERwin tool, getting a handle on your data architecture, now with the full integration of ERwin and the Casewise modeler, we can start to see now where you can look at impact of change, either to the data or from the data over to your process models, by extension then to your people, your organizations, locations, applications, and technology to better understand about how all these changes come to bear. So, our call to action. Today you saw a very brief review of the Casewise modeling set of products, but what we'd like to do is, if you're interested, is to arrange for a much more in-depth view of the ERwin tools, of the Casewise tools, and how they are in fact integrated together. And the person obviously to contact there is Mr. Robert Lutton, who I will pass the handle back to.
Great, Don, and actually just before we end this webinar, I've actually been monitoring the questions, and we have got a couple of questions. With me on the panel, we're going to bring in both Don and Dina, and also Ham Hayes, who's a senior architect working with Sandhill Consultants on the data and process side. Some of these questions may have been answered because they came in during the webinar, but the first question, there's 3 questions that I've got so far, and if people would like to ask more questions, please go ahead and just submit them to us. The first question is, where do you recommend the conceptual modeling be done, in the ERwin toolset or the Casewise toolset? And I'll open that up to the panel.
I presume we are talking about conceptual data modeling.
Correct.
Conceptual modeling is an interesting position because it's typically done by the business analysts. In either case, I would say both tools would be not a bad place to start. I would suggest possibly more on the ERwin side because Any conceptual model then should be transformable, at least in the data architecture world, to a logical data model. Obviously, that transformation and the set of rules and practices associated with it is probably better done in the ERwin because of the practices and the standards and processes. Dina, would you like to speak to conceptual data modeling in that respect, or conceptual modeling in Casewise?
Sure. Thanks, John. So I would probably agree with you. The only thing that I would say is if you're starting in ERwin, you can obviously do physical and all the other stuff as well. The logical part is what you would carry over into Casewise and then start linking it to your processes and to the rest of your enterprise architecture. So I think you can start in either place, and you can always end up in Casewise at the end.
And Dina, this is another question came in during the presentation, and this is a sort of a generic question or a generic answer for everyone. We have focused on one particular aspect of stepping up to enterprise architecture. There will be further webcasts and webinars that we will do with more in-depth specific features of the Casewise integration. But this one question came in is that you didn't demonstrate it, but could you explain how you exchange data from ERwin to Casewise and back again?
Sure, that's a great question. So the way it works right now is through an import-export. And so you would just take your information from ERwin and you would export that as an XML. And it goes through just a few-second bridge, which turns it into XML for Casewise. And so once you're in Casewise, you import that in. You can import that into a new model or an existing model. One of the benefits of this bridge is that it keeps all the unique information. And so even if you have a user-defined property in ERwin, you can bring that into Casewise, or vice versa. So if you have something user-defined in Casewise, you can bring that back into ERwin if you were to go back. So if you, for instance, are starting out from your logical side in ERwin, you import that into Casewise. And let's say you have your business analysts who are then looking at how their data links to their process, and they might want to add some attributes in Casewise. You can then take that information and bring that back into ERwin while keeping it still linked to your processes in Casewise. And so, the information goes back and forth. And as I said, you can bring in any of the user-defined stuff back and forth, and it's matched by a UID. And so you don't have to worry about the fact that someone might make an object with the same name in either one of the tool, in the other tool, because it will match by UID. And so if it's supposed to be the same object, you will update it.
And Dina, I believe that you, me, and Ham are going to be on a subsequent webcast where we'll actually be showing and demonstrating the integration between ERwin, the old BPWin, and going into Casewise and round-tripping back and forth.
Yep, exactly. So we'll show all of that. Yep.
Yep. So for people that are interested in that, stay with us. You'll get subsequent updates on that. One last question, and I think that Dina, this is for you because it's a Casewise question. Is you showed the Word document there, but is it possible to publish that to a website?
Well, absolutely. So it's very simple. Also, a lot of the things in Casewise are wizard-driven, so you can publish to HTML, which allows you to drill down through all your diagrams, be able to click on all the objects and see their information, see associations. You can customize the HTML, so you would have your own logos and style sheets. And so that allows you to very easily share the information that's in your model with a greater audience, people who might not be using the tool, but they want to be able to leverage the information that's in it. And so it's very simple to do. Yep.
Great, thanks, Dina. And again, we'll look into that in more depth in upcoming webcasts. So this is the first of series that we're going to be launching. We will post this recording up on our website. We will be able to send out the PowerPoints that Don and Dina had created. And with that, I'd like to thank our panel, Don and Dina and Ham. And we look forward to hearing some feedback from our attendees. Thanks indeed for attending, and we'll be in touch.